All right, so let's go ahead and jump into talking about wind and global wind patterns. And so, the very first thing you have to understand when we talk about how wind moves, and wind actually is going to be driven by the ocean currents as well. But the very first thing that you need to understand is some of its properties, some of air's properties. So warm air always rises. Warm air also holds more moisture than cold air. That's really important to know. Rising air expands and cools, and then that cooled air cannot hold as much water vapor. And after air cools and expands, it actually sinks. And so, because of this, it creates this cell pattern. And if we're talking about the cell pattern that occurs at the equator, we call it a Hadley cell. So there's a lot of direct sunlight that's going to hit the equator. I think we all know that. We've learned that for a long time, even in junior high, maybe even elementary school. But that direct sunlight hitting the equator actually causes the air to heat up. And so when it heats up, it's going to rise. As it rises, because it's moving further from the surface of the earth, and it's going to cool down in the troposphere, then it will actually cool and it'll expand. When it cools and expands, it condenses. So it goes from a gaseous state into a liquid state, and it will then condense into rain. Okay, and it'll fall back, and that's why we get a lot of really hot, wet, moist areas at the equator. I think of the tropical rainforests, especially. And so we end up with those at the equator for this reason. Okay, and so we've got the rain, and then the air will continue to rise. It continues to cool as it's leaving again the surface of the earth. When it gets to a certain level, it'll cool and it'll start to expand even further and cause the air to spread out. It'll actually spread back out as it's expanding here. It sinks, and then it'll sink back down until it happens that it kind of sinks at 30 degrees south and 30 degrees north longitude. And because a lot of that precipitation has fallen here and the moist air stays here, we end up with very dry conditions at 30 degrees north and 30 degrees south. Okay. So that this is an important concept to know. So I would maybe even draw a picture of this in your notes and maybe label a few things. You don't have to have this exact picture, but just so you get an idea of what is happening. And I don't think that you actually need to know the term Hadley cell. I think they've mentioned Hadley cells before on tests. So it might, it's a useful term to know. So I would make sure you write that down. Okay. Another thing that happens at the 30-degree longitudes is that we end up with high pressure, wind pressure or air pressure. At the equator, we have a low pressure. And so I think that's also very important to know. Okay, the Coriolis effect is another phenomena that's happening that you need to understand because it's going to help drive those wind patterns, those global wind patterns. And so the Coriolis effect actually deflects objects that are traveling through the atmosphere because of the spin of the Earth. So let's take a look. Imagine a baseball. If we were standing on the North Pole, which we can't do because it's an ocean, we were on a boat, let's say, and we threw a baseball and it was able to travel. Like there was no gravity, it was just traveling through. As the ball is moving through the atmosphere, the earth is actually spinning this way. And because of that, the ball does not travel in a straight line. We would expect it to kind of go on this dotted line, this path here, but it actually moves back from where it was because of the rotation of the earth. And so it actually does that in a bend. Because of this, air at the 30 degrees, so we have those Hadley cells, right, that have gone up, and now we've got air at 30 degrees. And it's going to actually come back down, but it's actually going to keep moving. And, ooh, let me go back. In this, I did not mean to hit the cursor, so let me see if I can get this back really quick. There we go. All right. So it's actually going to move in this arced kind of pattern. And the same thing happens here. We have the Hadley cells go up, the air comes down. When it hits here, it's going to travel back. And we keep having Hadley cells all over the planet. And so we end up with this air just constantly cycling, going up at 0 degrees, back down at 30, up and back down. And it's going to travel in this type of pattern. okay? And it's going to keep bending and moving. And so imagine this, bending and moving, okay? So that is, and I'll demonstrate this for you. I'll get a globe out and I'll actually show you how that happens. But that is what is happening. And then winds between 30 and 60 degrees actually bend in a different pattern. We call this a ferrule cell, how it's moving at the 60 degrees north. And so we will see that in another diagram here. Here it is. All right. So again, we have these Hadley cells driving the currents from 0 to 30. We have what we call ferrule cells driving the currents from 60. Okay. And then at 60, and then we have what we call polar cells that drive the air at the poles. All right, the ferrule cells are right here. Again, we get a lot of moist air here. They operate very much like the Hadley cells here, and then we've got the ferrule cells up here. Okay, all right, and so basically this air rising and sinking causes low pressure. And so we're going to have extremely low pressure again at the equator. We're going to have at the 30 degrees longitude, we're going to have high pressures. And then at 60 degrees, we're going to have low pressures again. Okay. So you can kind of see B, A are the polar cells, B are what we call the ferrule cells, and then C is the equator, the Hadley cells again. So explain how the sun is responsible for the pattern of air circulation that we see in cycle C. So you should be able to explain that and understand those Hadley cells. Okay, looking for the answer to this FRQ, you can find it on OneNote, and then as always, you can ask me in class. Let me know if you have any questions. All right, see you guys for our next set of notes, which is going to be on 4.6 watersheds.